The center of mass shifted due to or by adding the mass to the initial body. In that situation, how we calculate the shift in center of mass? For example, I am taking a square. 4 masses, M1 here, M2 here, M3 here, M4. All are equal masses. Center of mass is exactly at its center. When first mass is double, one of the particle mass is double. For example, this mass becomes here double. In the situation, here M, here M, here M, here also M. Now the mass is double. When mass is same, center of mass is exactly center. When mass is double, one of the particle mass is double. Then in this situation, the center of mass shifted like this. Because more mass this side. So, with respect to this diagram, center of mass shifted from here to here. What is the shift in center of mass? Same concept. Delta XCM is equal to added mass. Added mass into D by M1 plus M2. That means added mass, initial mass. Means total mass. Total mass. We can take as a M total. In case of removed case, and delta XM we get here minus because opposite direction. Delta XM we got here mass removed into D by mass initial mass minus removed mass. Here also you can write as here initial mass plus added mass as you wish. Here initial mass minus removed mass, nothing but remaining mass. Here total mass, that is the difference. Here there is no keep minus because central mass shifted towards the heavy mass. See here, added mass. Mass is doubled. One of the particle mass is doubled. That means here added mass is nothing but M. Initial mass is M. Now it is doubled. That means extra mass is M. Into D the distance between the central mass of the initial particles and 5. Initially the center of mass at this position. Now it is here. So that is given from here to here. Length is L. This value becomes here L by rho. By total mass is here 5. MM cancel. L by 5. In that way you can calculate. For example, I take a polygon like this. You have one problem on this. Mass is M. Length is L. Length of the side is M. Here also one of the mass is doubled. Initially center of mass is exactly at the center. Now mass is doubled this side. That means the center of mass shifted towards minus. When mass is doubled here, the center of mass is shifted towards heavy mass always. So what is the shifting? Here mass is one of the particle mass is doubled. Here also same M added into D by M initial plus M added. So in this case we get here see M added is M into distance from center of mass towards the position to added mass here. Nothing but L by a total mass M 6. Here mass is doubled. That means here 2M. 5M plus 2M. The M initial 6M plus M added M. 6M plus M 7M. So we get here L by 7. So the center of mass shifted from here to here. How much? M by 7. So that is the shifting in center of mass. Due to the by adding the mass or removing the mass. When mass is added, we can use this formula. When mass is removed, we can use this formula. In that we can calculate the position of the center of mass by which it is shifted from its original position. Just I give one more example concept on internal forces in case of the center of mass. So internal forces does not affect on the position of center of mass. How? See just a bomb of mass M. Initially it is at RG. Now it is exploded into number of pieces. Of mass M1, 3 pieces, M2 and one more piece, M3. M1 is on the y-axis, M2 is on the x-axis. What is the position of third piece? So I am saying a bomb of mass m explode in 3 pieces. M1 is lies on the y-axis, M2 is lies on the x-axis. What is the position where the third piece of the bomb is fall on the ground? So in that situation, you can use the center of mass concept. What is the velocity of third piece? Then you can use the law of conservation of linear momentum. Before blasting, the momentum is 0. After blasting, the momentum of the first piece P1 plus P2 plus P3 bar. So from that, the momentum of the third piece you can calculate is that P3 bar is equal to minus of P1 bar plus P2 bar. So magnitude, we have to magnitude. So in that case, you get here M3 V3 is equal to vectors of under root of P1 square plus P2 square plus 2 P1 P2 cos theta. So from that we calculate the velocity of the piece. But I am asking what is the position of the third piece, where it is fall on the ground. Either way, x-axis, y-axis, whatever it may be. So in that case, you can use the center of mass concept. After blasting, there is no change in position of the center of mass. That means the shift in center of mass is 0. We can use the formula simply m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. Delta xcm in this case is 0 because the bomb is explode due to the internal forces. Due to the internal forces, the position of the center of mass does not change. So m1 x1, that means the position of the first piece. I'm taking as here y1 or no problem x1 comma y1. Here position of the second piece x2 comma y2. Position of the third piece, where it is we don't know. Just assume x3 y3, that equal to question mark. Delta xcm 0, m1 x1 plus m2 x2 plus. From that this is also 0. From that we get the x3 value. And similarly also get the delta ycm is also here 0. So from that we get m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. Here also we get y3. So that is the effect of internal forces on center. Center of mass does not affect the internal forces. From the shift, there is no shift in position of center of mass. So you can use this form. Here x1, x2, x3. First particle, second particle, third particle coordinates after blasting. Here y1, y2, y3, same blast. There is no change in x position, there is no change in y position of center of mass. That's why delta x is equal to 0. From that you get the x3. From this also you get the y3. And one more problem: boat and boy or boat and dog. Just boat is floating on the water of mass capital M. A boy of mass small m is at one end of the boat. From the shore, the boat is at certain, the boy is at certain distance. For example, the length of the boat I'm taking is a capital M. For example, the boy walking from this end to this end. Here also the force acting on the boat due to the boy nothing but internal force. There is no effect of center of mass. There is no effect on center of mass. So in this case you can use the law of conservation of linear momentum as mentioned. When the boy walking from this end to this end, when he walks on the boat from one end to another end, the same time the boat is moving in opposite direction. Because boy is moving like this, the boat is moving in opposite direction by a small distance. He reaches from this end to this end, the boat is moving by small distance and taking as here x. That is the displacement of the boat. With respect to boat, the boy is also moves. So displacement system and taking as here x. In this case, you can use the law of conservation of momentum. Mass into velocity. Velocity of the boy. The velocity of the person. M into Vp is equal to minus capital M plus small m, because when boy is moving from here to here with the boat, the boy also in opposite direction. That's why I'm taking here capital M plus small m into velocity of boat. The velocity of person. From this, the velocity of the person or velocity of the boat we get here small m into velocity of the person by capital M plus small m. Here minus indicates opposite direction. What is the shifting position of the boat? Nothing but here velocity, nothing but displacement by time. So small m into the boy traveled from here to here. That means the walking distance is nothing but here length of the boat from here to here. We can take it as a capital. That is equal to minus capital plus small m into the shift covered by the system x. So the shift x equal to can take as a ml by capital plus small. That is the shift in boat. So in this case, boy walking from here to here. In the situation, the boat is moving along this direction toward the source, and boy moving away from the source. Boat moving toward the source. Now the boy moving toward the source. The boat moving away from the source. In the situation, just one problem. We are discussing one problem. Boy of mass 10 kg, boat mass 40 kg. The boy walking, the length of the boat and 10 years 8 meters. The boy just walking 4 meters. Not from here to here, just he is walking from here to here. That is, the walking distance of the boy is 4 meters. In that situation, what is the displacement of the boat, or what is the shift of the boat in opposite direction? Shift x equal to the formula m into L. L means length of the boat, not length of the boat, walking distance only. In this case, here to here, that's why that becomes length of the boat. That's why I am taking capital. But better to take length of walking distance. Here from here to here, we can take as here small using the formula. Mass of the boy 10 kg. Walking length 4 meters by capital 40, small m 10. So 40 by 50, 0, 0, 10, that is equal to you get here 0.8 centimeters or meters given data. So the shift of the boat in opposite direction is 0.8. Same problem, for example, from the shore, the boy is initially at a distance 12 meters. Boy is at a distance 12 meters. When he is walking through a distance of 4 meters, what is the position of the body, or what is the distance of the boy from the shore? Generally, when he is moving from here to here by a distance 4 meters, now that is 8, total is 12. He is walking from here to here, simply you can say 8, but that is 1. Why? When boy moving from here to here, the boat is moving in opposite direction. That means the boy is not exactly at 8, because the boat is shifted like this, the boat is shifted like this by a distance, small distance. So boy is at this position. That means we get here answer. The position of the boy in this situation from here to here plus shift. That means 12 minus 4 plus x. That is equal to 8 plus 0.8. That is equal to get the value 8.8. So that is that. For example, the boy walk from this end to this end by a distance 6 meters. In that case, we get here 60. So we get here 1.2. What is the position of the body? 6 meters. 12 minus 6. 6 plus 1.2. Now he is at a distance from the shore 7.2 meters or centimeters. So that is it. The same way, in place of boy, a dog is placed. As well as dog. A dog is walking from this end to this end. What is the position? Not only that, just for confusion, he give a straw of length 2 meters or 1 meter is float on the water surface. An ant is walking on the straw from this end to this end. What is the shift in straw? What is the shift in system? Same formula, x equal to mass of the boy into walking distance 2 meters by capital plus small m. Mass of the straw, mass of the ant, total mass in the same way. So that is the concept. So the same way, the center of mass problems is there. The shift is also due to there is no shift in center of mass. Position of the boy, position changes. The shift in center of mass due to the change of the shape of the wire. a wire of length L. Now it is bent into circular shape. What is the shift in center of mass? When it is circular shape, the center of mass is exactly at the center. So from this position, now the shift in center of mass is nothing but R. Here we know L equal to 2 pi R. From that R equal to L by 2 pi. Nothing but that is shift in center of mass when the straight wire is bent into circular shape. The same way, the straight wire bent into L shape. In that situation, what is the shift in center of mass? Just we consider x-axis. This is the y-axis. A wire of length L bent into L shape. From here to here it becomes L by 2. This also becomes L by 2. Mass of this M by 2. Mass of this piece also M by 2. X-axis, y-axis. This is one first particle. This is the second particle. So M1 is equal to M by 2. So the center of mass of this part, the center of mass of this part. Now I am considering these are the two particles now. When I am going to calculate decomposing method, when I am going to calculate of this shape, two particles. M1 is equal to how much? M by 2. M2 is equal to M by 2. The position of the first piece x1, y1, because here two pieces are in the plate x, y, y1. X1, that means from here to here L by 2. The position of the center of mass of the first particle is here. That means becomes here L by 4. So L by 4 comma 0. Here also the position of the second center of mass of the second particle. That is also here becomes L by 4. Total length here L by 2 of L by 4. So x2 y2 is equal to 0 comma L by 4. Calculate position of center of mass xcm. We get the formula m1 x1 plus m2 x2 by m1 plus m2. That equal to m1 m by 2 into L by 4. Okay, by 0. This becomes 0 by m. That means mm cancel we get here L by 8. Here also YCM also is there. YCM equal to m1 by 1 0 plus m2 y2 by here also we get L by 8. So the position of center of mass is here L by 8 comma L by 8. That means that is where it lies. That must be lies along the line joining the two particles. The center of mass of the first particle, center of mass of the second particle. So that is lies along this on axis at a distance L by 8 comma L. For example, at this position. So the coordinates of L by 8 comma L by 8 like this. What is the distance of the center of mass of this system from the origin? You get here under root of L by 8 whole square plus L by 8 whole square. So that is the change or shift of the center of mass due to change of the shape. Just one problem is there, no? Just general concept. We know at good mission mass is m1 and one more mass is m2. Moving downward. Here m1 is greater than m2, moving downward with an acceleration a1 and with an acceleration a2. It is moving upward, it is moving downward. m1 greater than m2. What is the acceleration of the center of mass of the system? Here a1 is equal to a2 because both are moving with same acceleration. One is moving downward, one is moving upward. So a1 is equal to a2. That equal you can take as here m1 minus m2 by m1 plus m2 into g. That is the acceleration of the first particle, acceleration of the second particle. What is the acceleration of the center of mass of this system? So we know the formula ACM is equal to basic formula m1 a1 plus m2 a2 by m1 plus m2. Here the two particles are in opposite direction. One is moving downward, other one is moving upward. So we get here opposite direction. That's why we can get here m1 a1 minus m2 a2 by m1 plus m2. Here a1 is equal to a2. So put here a, no problem. Take out common m1 minus m2 by here m1 plus m2 into a. A means acceleration of these particles individually. The same. So in place of you get here m1 minus m2 by m1 plus m2 into g. That equal to you get here same term. So you get here square m1 minus m1 minus m2 by m1 plus m2 square into g. That is the acceleration of the center of mass of this total system. Acceleration of the first particle, acceleration of the second particle, acceleration of the system. m1 minus m2 whole square by m1 plus m2 into g. If m2 is greater than m1, no problem, put here. m2 is greater than m1, then m2 minus m1, that's enough. m1 is greater than m2, m1 minus m2. What is the displacement covered by the center of mass in the time t seconds? Using formula s equal to ut plus half at square. Here initially the center of mass at rest, so it becomes 0. At square, a plus we get here acm. That is the displacement covered by the center of mass of this system in the time t seconds. What is the velocity of center of mass in the time t seconds? Using the formula v equal to u plus at. U is 0. The velocity of center of mass we can get here in place of acm into t. That is the velocity of center of mass of this total system at the time after t seconds. The displacement covered by the center of mass of this system after t seconds. The acceleration of the center of mass of this system, this one. So center of mass concept is over. Tomorrow we go to another chapter.